Okay, so we have a position of an object that's determined by this function here. The position as a function of time is 6t squared minus t cubed given that t is greater than or equal to 0. It says to determine velocity and acceleration. So velocity is a function of time. Remember that velocity is change in the distance divided by change in time. Right? This is the same as the derivative. The derivative of the position function. Okay. T approaches a particular point. Okay. And acceleration is the delta v divided by delta t. So as the change in time is infinitesimally small, this is v prime at t. So let's find this. This is going to be 12t differentiated minus 3t squared. Let me factor out the 3t that's common. Okay, and most of these word problems you really need to factor. Okay, you cannot get the answer in the expanded form. So you get 4 minus t. Differentiate, but differentiating it's easier to do it from here because you can use the power rule instead of the product rule. So you get 12 minus 6t. Again, let's factor out the 6 and you get 2 minus t. Now, the velocity at 2 seconds is going to be 3 times by 2 times by 4 minus 2. So it's 6, 2. So you get 12 meters per second. Acceleration at 2 seconds is going to be 6, 2 minus 2. So you actually get 0. So there's no acceleration. And that's meter per second squared. Okay, this is the answer to part A. So at what time is the object at rest? So if the object is not moving, that means the velocity, is 0. This is what it means for object to be at rest. Okay. So what that means is that we have to make this part here, the factor form, equal to 0. Okay, it's very easy to get the answer for t when it's already factored. Clearly, t is going to be 0 or 4. So therefore, at time is equal to 0 and 4, the object is at rest. Part C. In which direction is the object moving at t is equal to 5? Okay, again, velocity of 5. If it's positive, it's moving right. If it's negative, it's moving left. Okay, so plugging in 5, you get 3 times by 5, 4 minus 5. It's this that determines the answer. It's minus 15, so it's moving left. Moving left. Okay, if right is the positive direction. Let me see here. Yeah, moving on a straight line, right? So we're talking line is left to right, so it's moving left in this way. But this is the positive direction. This will be the negative direction. Okay, now for part D, when is the object moving in a positive direction? It's asking when is the velocity function greater than 0. So it's asking us to solve an inequality. Inequality of 3t, 4 minus t. When is this positive? I'm going to multiply both sides by negative here. I'm going to multiply negative in the bracket to get t minus 4. And the reason why I'm doing this, because this is a simple parabola that's going upwards with roots at 0 and 4. And when is this negative? Clearly right here. So when t is between 0 and 4, the object is moving in positive direction. Okay, we're trying to solve this, and our answer is this. So therefore, between, or I should say when t is between 0 and 4 seconds, object is moving in positive direction. Okay, lastly, when does the object return to its initial position? Okay, well, we first have to check what is the initial position. So initial position is when s at 0. Plug in 0, we get 0. in other words, it's asking you to solve when else is t, for what value of t, when else are we going to get s to be 0? So solve when this is equal to 0. So factor out t squared and we get 6 minus t, and we get two answers, 0 and 6. So this is referring to the initial position, okay, initial time, and this is the second time when the position becomes 0 again. So at 6 seconds, the object returns to initial position.